Hey comments, and welcome to this video. It was pointed out to me that there was a page in the packet from last week, honors, or the plus, math plus, the last page. We had not covered it before, so I thought it'd probably be good to put a video on about it. So here's that video. So if you're wondering what page am I talking about, I'm talking about this page right here. It's at the very end of the packet. It's talking about inequalities. Right? It says an inequality is any mathematical sentence that has an inequality symbol. Okay? Inequality just means not equal. So the solution set of an inequality is all values that make the inequality statement true. Again, solution makes the statement true, all right? Whether it's an equation or an inequality. So we could have the less than sign, the greater than sign, the less than or equal to, or the greater than or equal to. All right, and here is our example that they did for us. Step one. If we are graphing this on a number line, we plot an open circle on 2 on the number line. And the reason it's a circle is it's not or equal to. All right, x is less than 2, so it cannot be 2. So we're going to put that circle on 2. All right, and then it says, read the inequality, x is less than 2. This means that any value that is less than 2 will make the inequality true. So we ask ourselves, what side of 2 are all the solutions going to be found? Okay, since x is less than 2, we're going to find them on this side of 2. So we shade in this part, all right? And we use an arrow because anything less than 2, negative 20, negative a million, whatever, is going to be smaller. So that arrow tells us that we are going to continue on, okay? All right, so on this one, number 2, where it says negative 5 is greater than or equal to x, all right? So I'm going to write that on my board here. Negative 5 is greater than or equal to x. So what would our graph look like for solutions to this inequality? Okay, well, let's draw our number line. And when I draw number lines, I'm pretty lenient. I just kind of do a little sketch here. It doesn't have to be all filled out or anything. So negative 5 is obviously going to be on this side of 0. So I'm mostly interested in where's 0 and where's the number in question. That would be negative 5. So we would put it about right here. And then I'm going to ask myself, do I want a circle or a dot on negative 5? Okay? Can x be negative 5 and make the statement true? Well, it can, okay? Because negative 5 would be equal to negative 5. Okay? So since that's the case, I'm going to put a dot there. Okay? Now, if this line here was not here, it means that x would need to be less than negative 5. Okay? Which means it could not be negative 5, so we'd put a circle. All right? So we put a dot there, and then I ask myself, for x to be less than negative 5, what side do I need it to go? I need it to go this way, because this is where all the values that are less than negative 5 are found. Okay? So that's what my graph would look like for that. All right, let's look at the next type of problem. Okay, most of these are very similar. Again, be as close as you can to the numbers here. Now, solving inequalities. This is the part that we have not done yet. Okay, but I'm really excited that this is in the packet because you are going to need to know how to do this in the coming year. All right, so solving inequalities is really just like solving equations. Okay, so if you can forget for a second about the equal sign, or sorry, the inequality sign, and put an equal sign there, you'll be in good shape. Okay? The other thing about these equations is they are two-step equations. Well, inequalities, but you get the idea. Okay? So double level of difficulty. So good on you if you are pushing through this. It is going to pay off. Okay? Leaps and bounds. All right, let's look over here. Jenna's solution. Negative 4x is less than 20. She said that x has got to be greater than a negative 5. Okay, there's a lot to keep track of in inequalities, solving inequalities. Okay, they're challenging, but I love them. They're great. Okay, so I'm going to do the same thing as I would if this was an equation. So let's look at this. Okay, I'm going to go back to full screen here. Well, actually, I should have paid attention to what the inequality was first. Okay, I believe it was negative 4, I'm going to look, yeah, x is less than 20. Okay? So let's take a look at that. If this was an equation, so let's just think for a second, what if this was -4? Oh, and by the way, we haven't done negatives yet either. Crazy. All right, I guess they thought you guys could handle it. All right? So -4x equals 20. So we're going to divide both sides by -4, because what's happening to our variable? It's being multiplied. What's the opposite of multiplication? Division. So we're going to divide both sides by -4. Okay? Well, what's left over? Well, x would equal, what's 20 divided by 4? It'd be 5. Okay? But when we divide by negatives, we change the sign. Okay? Another thing we hadn't talked about. Okay? So if you multiply a number by a negative, it becomes a negative answer. If you divide a positive number by a negative, it becomes a negative answer. Okay? If you divide a negative by a negative, it becomes positive. All right? I'm sure you can find a lot of YouTube videos on dividing and multiplying negatives. All right. So I've got this would be a 5. Now, since this is not an equation, okay, like here, it is an inequality. So we are going to keep this sign in view, but here's a catch. Notice my negative. When I divide by a negative, something weird happens, okay? I tell my students this red siren should be going off in your head, woo, 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 because when you divide or multiply by a negative number, you've got to flip this sign or else it won't be true. Here's what I mean. If I flip this sign and I say that x is greater than -5, here's what we mean by that. Let's just take a look at that. Okay? -5 is over here, right? If I put a -5 in for this, okay? Well, let's go ahead and graph it, sorry. So x is everything that's bigger than -5. Oops, here's 0. Here's my -5. Okay, so I want everything that goes this way. So if I plug numbers into this inequality, okay, to make this true, I can't put anything greater than negative down here, okay, greater than -5. Because if I put a -10 in, for example, -10 times -4, like I said, would become a positive 40. Okay, positive 40 is not less than 20. So our sign had to shift, it had to flip, okay? That's why it was facing this way at one point, and then I turned it this way. Because now these numbers are going to be true. All right? For example, if I put a -1 into this statement up here, -1 times -4 is 4. Is 4 less than 20? Yes, it is. Okay, it works. What about positive 10? Okay, 10 times -4 is a -40, right? Because a positive 10 and a -4 make -40. Is -40 less than 20? Yes, it is. All right, so it works. So when you divide or multiply by a negative, you've got to flip the sign. Okay, got all that? All right, let's try another one. All right, number 1. -4x plus 39 is greater than or equal to -29. Awesome. Okay, this is going to give us a chance to do a bunch of things that we have not done yet. All right? So, let's take a look. What's happening to my variable? Well, it's being multiplied and then it's being added. Okay, the last thing that you said is the first thing you want to undo. The last thing I said was being added by 39. Well, what's the opposite of adding by 39? Well, it's subtracting by 39. So we're going to subtract both sides by 39. Okay? What's left over here? We got our -4x. And so far, I'm just going to bring my sign down. And now I've got a -29 minus 39. I haven't done addition and subtraction with negatives. Okay? Here's the rule. If it's a negative, if you're subtracting, we're going to change subtraction to addition. All right? So I'm going to think in my mind, -29 plus -39. We change subtraction to addition by adding the opposite. And when I have two negative numbers added together, they become more negative. Okay? So negative 29 plus negative 39 is like adding 29 and 39 together, but negative. Okay? If that's not working for you, go to a calculator. All right? I'm fine with that. Let's see. If I put in a negative 29, and the way I do that here is this, negative 29. There we go. And I'm going to subtract 39. Should get negative 68. All right. So I'm going to put that right here, negative 68. All right. Okay. And now I need to divide both sides by a negative 4. And remember, warning signs going off in our head, we got to change this sign. Okay? So x is now less than or equal to whatever this is. Negative 68 divided by negative 4. Okay? Negative divided by a negative is going to be a positive. Let's see with our calculator what that's going to be. I think I still have negative 68. Sure do. So divided by 4 negative. And that equals positive 17. Okay? So that is our solution. Okay? And we could do our graph on that as well. Okay? But I think it just says to solve each inequality. Okay? So there you go. All right. Give it a shot. Guys, this is very much beyond what we have done, but it is a great practice. If you want to try it out and see how you do, that'd be great. Email me any questions that you have. Thanks for watching. Bye.